In this part, we will review the substructure. I will take you through all the different types of foundations and their advantages and disadvantages. And most importantly, you will deeply understand the reasons behind the foundation choices. This deeper understanding will lead to questioning and further learning. We will specifically look at foundation overview, which will be followed by the foundation types, including strip foundation, raft foundation, pad foundation, piling, and within piling, we will review the driven, board, CFA, secant, contiguous, sheet, and pile caps and pile beams. We will then understand the requirements and needs of a damp-proof course and conclude this module with basements. Let's go. Substructure is essentially all structures below the superstructure, i.e. all structures below ground level, including the ground floor bed. It is usually everything below DPC, the damp-proof coursing. Although this definition is clear, it is a fairly ambiguous description. The Building Cost Information Service, BCIS, defines the term substructure as all work below the underside of screed or where no screed exists to underside of the lowest floor finishes, including damp-proof membrane, together with relevant excavations and foundations. It is suggested that the function of the substructure is to transfer the load of the building to the ground and to isolate it horizontally from the ground. According to the BCIS, the substructure includes foundations up to and including the damp-proof course, the lowest floor assembly below the underside of the screed or the lowest floor finish, the basement excavation, basement retaining walls up to and including the damp-proof course. Okay, now we know what a substructure is. Let's start with foundations. A foundation is a structure that transfers loads to the earth. Foundations help to avoid excessive settlement. Foundations are generally broken into two categories, shallow foundations and deep foundations. And we're going to go through both. So number one, shallow foundations, and they are typically used where the loads imposed by a structure are low relative to the bearing capacity of the surface soils. One common type is the spread footing, which consists of strips or pads of concrete or other materials which extend below the frost line and transfer the weight from the walls and columns to the soil or bedrock. This is also known as strip or pad foundation. Another common type is the slab-on-grade foundation, where the weight of the building is transferred to the soil through a concrete slab placed at the surface. This is commonly known as raft foundation. Shallow foundations are the most common types used for small buildings and domestic projects. The depth of these is generally less than their width, and they are commonly used for house extension foundations. Number two, we've got deep foundations, and these are necessary when the bearing capacity of the surface soils is not adequate to support the loads imposed by a structure, and so those loads need to be transferred to deeper layers with higher bearing capacity. Simply to transfer a load from a structure through an upper weak layer of soil to a stronger deep layer of soil. There are different types of deep foundations, including helical piles, impact-driven piles, drilled shafts, caissons, piers, and earth-stabilized columns. Did you know that historically piles were made of wood? Now they are made of steel, reinforced concrete, and pre-tensioned concrete. Taller commercial or residential buildings, or those built on very weak ground, will require deep foundations, which carry the load of the structure through the weak soil to the stronger soil or rock below. Foundations provide support for structures, transferring their load to layers of soil or rock that have sufficient bearing capacity and suitable settlement characteristics to support them. It is worth carrying out a soil survey before you decide which type of building foundation you require, as ground conditions have an important part to play. This is usually done by digging holes at various points across the site and using the results to assume the conditions throughout. And on this note, factors that determine the foundation choices are the total load of the building, ground conditions, so the nature and bearing capacity of the subsoil. This includes how much water is present, the amount of settlement produced by the loading, space availability and proximity to other structures, accessibility, sensitivity to noise and vibration, cost, and load exerted on the piles. So, One of the points just mentioned to determine the foundations is the different loads from a building. You have dead load, which are all the materials in the structure, live load, which are people using the building and furniture, etc. And you've got superimposed load, which are natural Mother Earth loads like wind or snow, etc. Buildings with larger loads will need different foundation solutions. For example, raft or strip foundation wouldn't suit a building with a large load such as a car park. Piles may be more suitable. Okay, let's look at the three images. Firstly, the main function of a foundation is to safely carry and transmit the loads of the building, both dead and live loads, to the subsoil. And as you can see from the first image, the soil resistance is adequate and the building load is therefore stable. Secondly, the foundation should balance the building loads with the allowable bearing capacity of the local subsoil. However, in this case, the subsoil and resistance are inefficient, and so settlement occurs. There is no foundation in place to prevent settlement. Thirdly, where a foundation has been created, either a strip, pad, or raft foundation, the soil resistance is totally fine. In this case, the foundation distributes the building load to an adequate area of bearing soil in order to avoid settlement. Remember, the building load can come from three different types of loads: dead load, live load, and superimposed load. And looking back at some of the factors that affect the foundation choice, the type of building is one of the main factors. And there are three types of building which can affect and which will affect the foundation choice. You've got number one, unframed buildings, number two, partially framed buildings, and number three, fully framed buildings. Let's look at these in a little more detail. Number one, unframed buildings. The term unframed means that there is no skeleton of steel or reinforced concrete taking the load. They are all essentially load-bearing walls, and you can see from the image the unframed building load path. Two, partially framed buildings. Partially framed buildings characterize those which are halfway between the framed and unframed, i.e. buildings containing a share of each. The external walls from the unframed section, as they are load-bearing, and the framed section comprises posts and beams erected to replace load-bearing internal portions. Partially framed buildings of an old-fashioned type usually incorporate timber posts and beams, providing support for timber floors, or cast iron columns moulded for strength and appearance, and beams of iron and timber. In more recent buildings of this type, however, columns and beams are constructed of steel and are similar to those used in modern fully framed buildings. And three, we've got fully framed buildings. So fully framed buildings are so described because they have a skeleton frame which carries all the loads, including the weight of the walls. The frame may consist of steel, reinforced concrete, or timber. Foundations are usually formed individually and may consist of comparatively small blocks of solid concrete, large reinforced concrete, or steel joists encased in concrete. The frame is formed fixing the stanchions to their concrete bases and fixing between them at suitable levels, steel beams which will support the floors and transmit the load to the stanchions. These stanchions or beams may be encased in concrete or brickwork to protect the steel in case of a fire. When the frame is of reinforced concrete, steel rods will be incorporated in the concrete in place of steel stanchions and beams. You can see in the image the frame building load path. Okay, let's now have a look at how foundations are created. Here we have the basic process, starting with the topsoil strip, excavating to reduce levels, setting the site out, and preparing for the foundations. Then excavating the foundations and pouring the concrete. This process would be very similar for all types of foundations, such as strip, pad, and raft foundations. Let's look at these steps to create the foundations in a little more detail. Number one, excavate trench. Number two, disposal of excavated material. Number three, earthwork support. Number four, compaction. Number five, binding. Number six, hardcore. Number seven, formwork. Number eight, reinforcement. And number nine, concrete. Let's now go a little bit deeper and see step by step how to create the foundations. This perspective is if you are going to create them yourself, but they also apply to the workplace where you have many other professions such as designers, site managers, project managers, all contributing. Your finished structure will only ever be as good as the foundations it is built on. So if you are in any doubt about which type of foundation to use, get expert advice from a building inspector or structural engineer. Of course, if you are working for a larger firm, this information would already be provided to you. Firstly, you would prepare the ground. It doesn't matter how big or small your concrete pour is, the first step, once all relevant permissions are in place, is to prepare the ground. The area where the concrete is going to be poured will be marked out based on the correct setting out, allowing an extra 75 millimeters to accommodate the formwork, which will hold the wet concrete in place when it is drying. The foundations would then be dug to the required depth. For strip footings or strip foundations, this is generally to undisturbed solid ground, while for individual footings or pad foundation and floor slabs or raft foundations, you will need to allow enough depth for your sub-base, normally 100 millimeters, and damp-proof membranes, the DPM, as well as the concrete itself. This would be much quicker and easier with a small mechanical excavator, providing access allows. However, depending on the size of foundations required, the level of plant required will change. All debris, stones and plant materials must be removed before levelling and compacting the soil to create a level base. Next would be to add your sub-base and compact again. For most smaller projects, for example primary schools, 100 millimeters of base aggregate is adequate. A DPM is then laid, ensuring the edges are turned up to form a tray and any joints are overlapped and taped. This is to protect the underside of the concrete from rising damp and any chemicals groundwater might bring in contact with the concrete, as well as helping to prevent it drying out too quickly due to water being drawn into the sub-base, which will improve the final strength and reduce the chance of it cracking. The next step would be to build your formwork, which is usually made from well-supported 25 millimeter thick timber planks to keep the concrete in place until it has had the chance to set. The formwork needs to be as deep as the concrete slab will be. Next, we will lay the concrete. Once the site is prepared, the concrete is ready to be laid. As well as the type of foundation, it is also important to know which type of concrete to use. Soils which contain sulfates, for example, can attack concrete over time and cause an expansive reaction. The depth of concrete that will be needed will depend on the use. Footings for small projects, for example, will need to be at least 200 millimeters thick. Next, you would need to use a concrete pump. Using a concrete pump is perfect when you are dealing with large volumes of concrete or when time is tight and you don't have the manpower to use wheelbarrows, for example. You can pump approximately 1 meter cube of concrete per minute. You will also need to use a pump if the concrete mixer truck can't get close enough to the pour area or access to your site is restricted, underground, within an existing building or at a height. Next, it's pouring the concrete. So concrete typically starts to go off within 2 hours of being mixed, so this action must be completed quickly and planned thoroughly. The actual time will depend on the type of concrete and the ambient temperature. In cold weather, it can be twice as long for the concrete to set. In hot weather, the setting time could be reduced to 30 minutes. As a result, the concrete will need to be unloaded and leveled as quickly as possible. A rake or shovel would be used to move the concrete around and roughly level it and straight edge piece of timber to tamp down the concrete and eliminate any air pockets. The concrete is usually wet enough that it could be pulled around the trench using rakes before the surface is leveled out and tamped down to remove any air trapped. This is most efficiently achieved using a suitably sized vibrating poker. When the surface is compacted to the marked out level, it can be smooth and leveled with a conventional hand float. It's important to make sure that there is enough room on site for the delivery truck. They are around 9.5 meters long, 3 meters wide and 4 meters high, with a turning circle of about 17.5 meters, and they weigh up to 32 tons. This is something the project manager would be aware of. However, as a quantity surveyor on one of my projects, we had some enabling works which had to accommodate vehicle turning points, and therefore this added cost during the cost planning stages. So bear that in mind. Ready-mix concrete trucks have extension ramps that can reach around 3 or 4 meters. So unless the concrete can be offloaded at various positions around the site, you may need to use a concrete pump. If you are using wheelbarrows, manpower should be made available to speed up the job. as 1 meter cubed of concrete will fill around 30 to 40 wheelbarrows. Paths to the pour should be cleared and planks laid to deal with any slopes or uneven ground. It is not advisable to lay concrete in any adverse weather conditions, but if it is unavoidable, there are a few things to consider. The minimum air temperature to pour concrete is 3 degrees Celsius, to make sure that ice doesn't form within the mix, which could compromise the strength of the concrete. You should also never pour on top of ice or frost, so if this looks likely, protect the subbase by insulating blankets or thaw with heaters before the pour. You could pour concrete in the rain as long as the ground drains well and there aren't any rainwater pools. Once it is poured, cover using a tarpaulin or sheeting while it cures. Heavy rain will damage the surface of the concrete, so if appearance is important, make sure there is a cover to keep the rain away until you are happy to apply the final finish. The concrete will be reasonably wet when it is poured, so a shovel or rake would be used to roughly level the concrete. A straight edge piece of timber can then be used to tamp down the concrete, eliminating any air pockets. Repeated tamping will create a reasonably smooth surface, but a steel float trowel could be used as the concrete starts to harden for a finer finish. And it is worth noting the smooth concrete can be quite slippery, so often a rough, tampered or brush finish is preferable. Next, it's about curing your concrete. It is important that the concrete doesn't dry out too quickly as it hardens, as this could cause a weak, dusty surface. The easiest way to achieve this is to keep the slab damp by covering it with plastic sheeting, making sure the edges are sealed to prevent wind tunneling effects. This is particularly important if temperatures above 20 degrees Celsius or if there is a stiff breeze that could dry the surface. Also, if temperatures are likely to dip below 4 degrees, a frost blanket or similar should be used to insulate the slab and protect the surface from frost. Follow-on work should be possible within 48 hours, although it is worth checking with the concrete supplier, and it is best to leave any formwork for 72 hours to avoid any possible damage to the edges of the concrete. The building inspector may also insist on examining the concrete foundations before any bricks or blocks are laid. So make sure you have checked before you start the next phase. Concrete takes 28 days to reach its full strength.